So we are doing the last section of notes in this note packet. We're looking at how do we measure pH typically, and then also titrations, because that's where we're going with our lab here. So just a couple things. Obviously, to measure your pH, we've mentioned a couple of these before. You can use an indicator. The most common ones are litmus paper, phenolphthalein, which we're actually going to use in our titration lab, our first titration lab. Cabbage juice is a really good one, and hydrangeas naturally do it because it has the anthocyanins in it. You can also use a pH meter, and they actually give you like a numerical value, which is nice. If you take AP Chem, we'll use some of those. And just remember with pHs and stuff, the sig figs are kind of wonky. Remember, like, you start out with 2 sig figs in your concentrations, and those sig figs are your decimals on the pH. So just keep that in mind. So the last thing we're looking at is that we're going to be doing titrations. So a titration is basically you're adding an acid to a base, or you're adding a base to an acid. And what it is it's very carefully controlled. So you're neutralizing the acid or the base that you have, and you're just doing it really carefully. What happens here is you have one of your components, your acid or your base, you know everything about. You know your concentration, you know how much you use. And then one of them is you don't know the concentration of. So what you're trying to do is you're trying to find the concentration of either an acid or a base, depending, and by neutralizing with something else. So the first thing with a titration is you're using a burette, and you'll see burettes in the video you're going to watch. They're very, very accurate. They look like kind of like giant test tubes, but they have this thing at the bottom that you can open and shut to release very accurate amounts of volumes. Your standard solution is whatever you know. So it's either the acid or the base, but it's the one that you know the concentration of. And you always add an indicator so that you can see when your titration's done. And then what happens is you add your standard solution to your unknown until you get a neutralization. And you pick the right indicator so that when you reach this equivalence point, that the indicator changes color. And when you have an equivalence point, what you have is your equivalent. So the moles of your acid is going to equal the moles of your hydroxide. And just remember, the way my thing is, this is really just moles of H+, but remember it's underlined, and it even underlines the upper part here. And this really is just moles of OH. It's just the same thing with the underlining. Remember, when the indicator changes color, it's called an endpoint. And not every indicator is appropriate. Like, you have to pick the right indicator for the pH that your neutralization is going to occur at. And again, you want one where that endpoint is at that equivalence point, so it works. For us, since we're just going to do strong acid and strong base titrations, we can do a really simple stoichiometry of it. So we're going to show you how to do that. Excuse me. And basically, how do we do that from that? You're going to get a worksheet to practice it, and you want to make sure, obviously, that you know how to do the titration problems. All right, so here's a classic example. What we have is at the end point of a titration, which this would also be the equivalence point. What we did is we had 50 mils of 0.15 molar sodium hydroxide. So that was the known solution. And we titrated it, and it neutralized exactly 30 mils of an acetic acid solution. And we want to calculate the molarity of the acetic acid, and this is a very common thing here. So the first thing we're going to do is we're going to type up what our reaction is. Well, you're going to write it, but I'm going to type it. So what we have here is we have NaOH, and we are adding it to acetic acid. So remember, acetic acid comes from acetate for that one. It's a reaction, so I'm just going to do my little arrow. This is a double replacement reaction, so we're going to make sodium acetate, and I'm going to make water. So what we can do now is we can actually do a stoichiometry problem here. And just keep in mind, we know this is 0.15 molar. We don't know this guy's molarity. We know that we use exactly 50 mils of this guy, and we use exactly 30 mils of this guy. So what we're going to do is we're going to start with the thing we know the most about. And mine's going to be written a little weird just because I'm typing, but same kind of thing here. So what we know about sodium hydroxide is we have 0.15 moles of NaOH divided by 1 liter NaOH. So again, you're going to have to bear with me here because I'm typing. So that's our first section of our stoich. And this is just our molarity. Remember, molarity is moles per liter. So what we want to do is we want to get it out of molarity and we want to get it just to liters. So what we're going to do is we're going to multiply, which is my little x here, and we're going to do that, oh my, where is silly thing? We're going to multiply by our liters on top, so it cancels out. So what it looks like on top is we have 50 milliliters, and remember to get to liters, we're going to divide by 1,000. So it's 0.050 liters. And remember I did that just by dividing by 1,000, just back to good old stoich. And it's not, you can put it over 1 or whatever, it's just, we're basically just, we're multiplying these guys so the liters cancel. Alright, next thing we're going to do now is we're in moles of sodium hydroxide, so we have to do a mole ratio. So we want to go look at our reaction up here, because it's not always 1 to 1, and we want to see, okay, how many moles of sodium hydroxide do we have versus how many moles of acetic acid we have. And it just so happens that we have 1 mole of acetic acid for every 1 mole of NaOH. And I just got that right from my balanced reaction that we had written up here. Ooh, what did I do? What did I do? Sorry about that. Let's see if it still likes me. Okay, hopefully you're still with me. I tried to ununderline and I went crazy here. So, last step here is now we're in moles of acetic acid, and what we would want is we would want it in liters. So, what we're going to do here is just basically divide by our liters of our acetic acid, what we have here. So, if we do that, we have 30 mils, or we have 0.030 liters of the acetic acid. And what you'll end up with is you'll have your moles of acetic acid divided by your liters of acetic acid, and when we do that, that equals exactly 0.25 molarity of the acetic acid. So by using this rough stoichiometry, you're basically just doing stoichiometry with the titration. So what we're going to do on Monday is you're going to have something that you know, I'm going to give you something that you don't know, and you're going to try and figure it out using titrations with it. So hopefully that helps, and hopefully you can try some of the practice ones.